In this instruction video we will show you how to set up and work correctly with the Beveltools EBI 3.0, the ABIS-R, the ABIS-B, the EBI INOX and the ABIS INOX. Before you start setting up the machine, make sure to disconnect it from the power source. When placing a cutter, make sure you check the adapter and shear pin. If one of these is damaged, you should replace the part in question first. This is vital to get the expected service time out of the cutters. If you place the cutter on the adapter, make sure the pinhole of the cutter covers the shear pin on the adapter correctly. The cutter must now be mounted flush on the adapter when you have done this. Use a hex wrench to fasten the cutter with the guide bearing that comes with the cutter. Always keep these two together also when you change the cutters. To prevent the spindle from rotating, press the locking button of the machine. Apply the proper torque, 5 to 7 Nm, to tighten the guide bearing with the hex key wrench. Setting the correct depth. When adjusting the flange head, you can hear little clicks every 45 degrees when you rotate the adjustment sleeve. Each click is signaling that the depth is adjusted with 1/8 of a millimeter. So, 8 clicks in the same direction means 1 millimeter difference in height. When you want to bevel deeper than 4 millimeter at once, make sure to take multiple steps to divide the load on the cutter. For example, when going to 6 millimeter depth, divide the height in 2 passes. When you are applying a rounding, make sure the flange is aligned with the start of the radius arc. When cutting the edge, it's very important that the guide bearings has enough support from the edge of your workpiece. The minimum amount is about 1.5 to 2 millimeter of support. When the remaining height of the edge is lower than 1.5 millimeter, you need a mold or put 2 equal workpieces exactly on top of each other. In most cases, the flange will be placed horizontal on the workpiece. In this case, the chips will fall down below the flange. It's possible though to turn the flange in a vertical position. Be aware that chips now will fly upwards, to the right, left, and downwards. When cutting edges of lighter workpieces, make sure these are clamped properly on a sturdy surface. This will prevent the workpiece from sliding away during the cutting process, and will decrease vibrations. Remove slag if present. You can add some lubrication, especially when doing cutting jobs on stainless steel. Make sure you wear your PPE. Plug in the power plug. On the electric EBI, set the speed to the highest position, which is 6. With stronger or harder materials, lower the speed of the machine. Keep the machine on the left side of your body. Place the edge of the flange on the metal sheet, bar, or workpiece, without touching the metal with the cutter. Touching the metal edge with a stationary cutting head can cause minor damage to the cutter, which can decrease the lifetime substantially. Now turn on the machine and press the cutter from your left side into the edge. Be aware of some recoil of the cutter when it grabs the edge. Hear and feel when the cutter has reached the correct cutting depth, and the guide bearing is touching the side of the metal. Slowly turn/rotate the machine during the first inches you are cutting. You will reach the position where you can push the machine forward, with the EBI in an angle of circa 45 degrees facing to the right. Keep the machine in this position while moving forward. The forward speed of the machine is important to keep the cutter fed. This is the most important way to increase the lifetime. Inside a hole, you will be moving the cutter head clockwise. When you reach the right forward speed, you will hear the speed of the motor dip in. Adding some cutting oil, grease, or foam can give a cleaner end result and can lengthen the service time of a cutter. Working with the EBI INOX and ABIS INOX is somewhat more intensive than working with, for example, the EBI 3.0 on construction steel. Make sure the cutter is fed enough material to increase chip thickness and lifetime. Your forward speed will be somewhat slower on stainless steel because of its characteristics. Try to reach a forward speed though of 2 meters per minute. Always make sure the workpiece is tightened so it can't move or start vibrating. Thanks for watching.